In the last few videos, we sort of had a general introduction to matrices, and we talked about a few special types of matrices by restricting their entries, their order, and so on and so forth. Let's talk about one of the most basic operations in any sort of algebra, where it's the algebra of real numbers or complex numbers, and that is the equality. The equality. So basically, you say that a number A is equal to a number B if they both lie on the same place in the number line. So like 2 plus 2 and 4 are equal. Common sense. In a similar way, you can also say two matrices would be equal, and it calls for two conditions. It calls for two conditions. First, they both have to be of the same order. They both have to be of the same order, have to be of the same order, So that is, they both have equal number of rows and equal number of columns. Since if they don't have that, the two matrices just can't be equal. And the second constraint is that each element of A would be equal to each corresponding element of B. So that is to say, if you write A as Aij and B as Bij, then Aij should be equal to Bij for all i's and j's, So let's do a quick example. Let's do a quick example of equality of two matrices. So let's say you have x plus y 2 in the first row. In the second row you have 2x minus y, and that is equal to the second matrix that you have 5 2 2 3. So now you have to solve for x and y that make these two matrices. Let's say this is A and this is B. So that you have to solve for values of x and y that make these two matrices A and B equal. So 2 equals 2, 2 equals 2, both of them are satisfied, so you don't worry about these entries right here. You have x plus y equals 5. So x plus y equals 5. First row, first column of A equals the intersection of first row and first column of B. Similarly, you have x minus y equals 3. X minus y equals 3. And once you solve these equations, let's say you add them up, then you have 2x equals 8, so x equals 4. Plug x equals 4 back in this equation, so 4 minus y equals 3, and that means y would be equal to 1. Really easy, fairly easy. The equality of matrices, though, is really an elementary operation. It's just taking each element and be equal to one another. The problems can be extended as much as you want them to be. So let's do one more example. So let's say you have a matrix that has all variables, none of the entries is a constant, and it is in the first row you have 2a plus b and a minus 2b. In the second row you have 5c minus d and 4c plus 3b, and that is equal to the matrix 4, -3, 11, and 24. And so you have four variables to solve. You have to solve for A, you have to solve for B, you have to solve for C, and you have to solve for the variable D. And you also have four equations out of this. So let's write the four equations. So let's start with 2a plus b equals 4. 2a plus b equals 4. Let's then do a minus 2b equals minus 3. A minus 2b equals minus 3. Let's do a third one. So 5c minus d is equal to 11. 5c minus d equals 11. The fourth equation in this case would be 4c plus 3b equals 24. 4c plus 3b equals 24. So now it's totally dependent up to the problem of how it sets the mood for making the variables. In this problem that I chose right here, you can easily see that if you add these two equations up, if you sort of solve for a and b in this equation, you can get nice values. So let's multiply equation. Let's name these equations. So equation 1 and equation 2. So let's multiply equation 1 by 2 and add it to equation 2. So multiplying equation 1 by 2, all the terms multiplied by 2 give you 4a plus 2b equals 8, and equation 2 is a minus 2b equals minus 3. You add them up, so the 2b's cancel, and 5a is equal to 5. So that means a is equal to 1. You take a is equal to 1 and you put it into the equation 1, 2a plus b. So 2 times 1 plus b is equal to 4, and that means b is equal to 2. So you have the values for a is 1 and b is 2. What you can do is you can see in the fourth equation that we have here, you already know the value of b, so you put it there. So 4c plus 3 times 2 is equal to 24. So that means 4c is equal to 24 minus 6, that is 18. And once you have done that, once you have found that, you just basically write c equals 18 over 4 or 9 over 2. Now, if you plug 9 over 2, if you plug 9 over 2 into the third equation that you have, once you have got the value of c, you get 5 times 9 over 2 minus d is equal to 11. And you can solve for that. You can solve for d, and d would be equal to 45 over 2 minus 11, and that's equal to 45 minus 22 over 2, and that is just 23 over 2. So you have sort of solved for all of these values, and that accounts for a nice introduction to the equality of matrices. You can really extend it to any number of variables you want to put, but the idea remains the same. Two matrices would be equal if they have the same order, and each element of one matrix is equal to the corresponding element of the other. You could also extend this. You could also say A equals B and B equals C, then A must be equal to C. So sort of the general understanding of equality of numbers applies to matrices as well. Whatever properties you have for the equality of numbers, you just apply the same to matrices, just the operations would be element-wise. See you in the next video.